Welcome back to another session of the Observability Expert Insight Series, the EIS. And it is a progressing series presented to you by Cisco CSS on topics driven by customer feedback and focused around hands-on demonstrations so you get the most out of your time spent with us. And all of it will be recorded and posted up on our YouTube page, which I posted in the chat. So if you have any questions on that, please feel free to ask on those. And I'm your host, Christopher Bonanno, and I'm pleased to welcome back our presenter today, Mark Kerpiel, who is continuing to deepen our knowledge on Splunk AppDynamics Synthetics. Mark, the floor is yours.
Thank you, Chris. Hey, everyone. Welcome to the Splunk AppDynamics Expert Insight Series Synthetics, Session 3 on Advanced API Script Building. My name is Mark Kerpiel, and I'm a Customer Success Engineer here at Cisco, and my job is to enable you on Splunk AppDynamics so that you can get the most value out of your product purchase. For today's session, we will be posting the GitHub in the chat for what I'm covering today, so you can follow along or do it later at another session. Do it later after the session. And this is the third session of our synthetics series, where we go in more in depth into synthetics by covering advanced API script building. And just in case you missed our first two sessions, we did first do an overview of synthetics and how to create simple synthetic scripts. And then our second session, we covered advanced browser script building. And if you missed either of them, please check out our recording, which we'll post in our YouTube channel, which we have linked in our chat. And this series does build on itself, but if you haven't seen the first two, don't worry. I think you'll still be able to follow along with today's session. As well, we're going to be doing a series on dashboarding and then a log observer next, so please don't miss those. And this is an open forum, so feel free to leave questions in the chat as you think of them, and our panelists will answer them directly, or will stop and answer them live in the Q&A portion of today. And for our agenda today, we'll first show you how to configure your API monitoring scripts. Then we're going to move on to some best practices and some cool tips for your synthetic monitoring. Then we'll cover how to set up proactive monitoring properly to help you get the most out of your synthetic jobs. And then we'll do a live demo where you can follow along, covering all these concepts and showing you how to create your first complex API synthetic script. And then finally, we'll have a Q&A and then finish with some closing thoughts. So let's get started. For synthetic API monitoring, we have a few job configurations that we need to consider to make sure that we set the correct conditions for our job to ensure that we're reflecting our real users' journeys. The first being how we create our script, whether it be through the UI, through the script editor, or by importing a Postman collection. All of these options I'll go into more in detail in the next slides. The next option would be selecting the location. Here we want to consider private versus hosted locations, as well as what regions we want to test against our APIs. This is great for geo-distributed testing, where we can see if issues occur only in specific regions against our API endpoints. Then we'll set a schedule. This should reflect when we want our test to be run. For example, if we only want it running on the weekends to make sure our APIs are always being tested, even when there's no real user traffic. And then our next setting, we'll set our timeouts. For our timeouts, we want a good balance here. We want to make sure that we're not getting false alerts with a too low of a timeout second chart. But we also don't want our scripts to run too long in a timeout situation and then bleed too many license usage. And then finally, we want to set thresholds for performance events on critical and warning. These events are then perfect for creating alerts, which I'll get into later. And remember, when we're configuring our jobs, we want to consider the real use case when we're testing our APIs, and then configure our jobs based on that real use case. Now, speaking of our script configuration options, the first one we have is a no-code option using GUI, which is great for quick setups or for users less familiar with scripting. With our GUI, we have a simple interface to allow even those with no code knowledge to create complex API scripts to follow user journeys. And this is done by giving you all the appropriate options needed for any API test, such as authentication and response validation, as well as custom variables and the ability to anticipate redirects. These options make it easy to tailor synthetic monitoring to your environment and to your needs. And a cool thing is with the GUI is once you save, you actually create a script that you can change in the editor. And this can help you learn scripting or just allow you to quickly build a script template and then make more customizations manually after. Now, a lot of you already have API scripting using the Postman, and if you do, great. AppDynamics makes it easy to convert those tests. All you have to do is right-click your collection in Postman, go to More, and then click Export. When you are exporting, make sure you click the collection version 2.1, not 2, as AppDynamics doesn't support 2. And then in AppDynamics, all you'll have to do is then create a job, click on the Import tab found here, choose your exported file JSON, and then click Import. This approach not only saves you time, but lets you reuse existing test logic. And it's also a great method of testing your logic locally before bringing it into AppDynamics. Now, for those of you who want more advanced control, the script editor lets you write JavaScript directly. And I recommend everyone watching to learn to edit your scripts, as it's the best way to get the most out of your API synthetic experience. Now, it does seem daunting, but once you do a few, and I will include a few in the GitHub as well as we'll walk through a few today. Once you get a few through your belt, you'll feel really comfortable with it. And with our script editor, you can use JavaScript with the GOT library to make API requests. And AppDynamics will then automatically create a client object for you to use. And then the script customization is pretty endless from there. And it really just ends up being up to the limits of your imagination. And I'll get into that in the next slide, but we do recommend developing and testing your scripts locally in an IDE first, such as Visual Studio Code. That way you can use breakpoints and help debug and refine your scripts before importing them into AppDynamics. I really recommend that for complex scripts. For simpler ones, you might be able to get away with just doing it in AppDynamics, but I'll get into that into our demo later. Now, speaking of scripting, let's give you some tips to help you get the most out of your synthetic scripts. The first I recommend is using logging when creating scripts. This helps anyone that's debugging your sessions with troubleshooting by giving important context. This can be things such as looking for specific responses in codes, saying that let's say you know specifically that this response returns a 203. You can let the person debugging that know specifically with their console logs. So it adds a human element into your scripts. We also then have a built-in encryption library and decryption library for security situations, such as XML signings or JWE encryption or decryption. And the included libraries are Jose, XML Crypto, XML DOM, and Crypto itself. We also want to wrap our code in try-catch statements. Now, these try-catch statements help us manage errors gracefully and keep our scripts robust. And then we also want to use assertions. These assertions can be used to validate API responses and catch any deviations. This is the real way that you actually test your APIs correctly, just like any other API tool such as Postman. And then you can also do XML parsing. So when dealing with XML APIs, you can make sure to parse and validate responses as needed, and I'll show that off in the demo. And then finally, we can use dynamic variables for situations such as storing access tokens from a response and then using it as an authentication for other calls continuously. And these best practices help sure that your monitoring is reliable, secure, and easy to maintain, and help us to best reflect what our real user journeys look like, no matter how complex they might be. Now, an underrated page within your API monitoring is the APIs page. You'll find it on the left-hand side, and a lot of people don't even click into it. This is the control center for your targeted monitoring, where you can focus on specific HTTPS API endpoints for detailed visibility. And this platform aggregates performance and availability data across jobs for each endpoint, giving you a comprehensive view. And then you can then build custom dashboards and set up alerts for your most critical APIs. This is useful for business critical endpoints, such as your login services, which will be hit by multiple jobs. Also, another thing to note, and this is great for alerting and for understanding specific metrics, There is a difference between the duration on the APIs page and the sessions page. The job duration includes the full script, including validation and so on, but the API duration is just for that specific individual API request. And that's really important, again, when creating alerting or creating dashboarding. Now, another great feature that people don't even realize exists, I know a lot of people that I've had to teach this to, is BT correlation. This is a powerful feature for root cause analysis, as it links your synthetic monitoring sessions with real business transaction snapshots in AppDynamics APM, so you can quickly trace issues. And thankfully, it is simple. All you have to do is ensure that your APM agent is installed and your BTs are configured correctly. Then the API synthetic agent will send a special header to signal a BT lookup. And then your APM agent will respond with a cookie containing your trace info for that specific for that specific APM snapshot, which enables the deep correlation in AppDynamics. To view this in action, all you have to do is navigate to a session, select an API that is related to an APM agent, then click on the business transaction tab for detailed diagnostics, and then you can go into the actual snapshot itself to help determine the root cause of your issue. This is important for troubleshooting sessions. Let's say you're getting an API request, you can't figure out why your synthetic is failing. You can do a deep dive on the APM side, see exactly what's going on. And this gives this is a great point as well. Like I mentioned, you can run synthetics in off hours when real users aren't giving you data on the APM side. And because of synthetics, you now have a real APM data to look at from your synthetic scripts. So you can catch during off hours, such as post-release, you're doing it at 2 or 3 a.m. when there's no real users, or the weekends, let's say your application's internal and there's no employees logging in on the weekends. You can do validations during those off hours. And now once we set up our synthetic jobs, we do want to make the most of them by setting up proactive monitoring. For that, we do have some options. The first being custom health rules, where we can monitor the entities of either API endpoints or synthetic jobs, and then create static and dynamic thresholds against our metrics, such as availability or script errors. And these can be great for monitoring things against your SLAs that you're given for your organization. And then once these events trigger, we have events that we can trigger actions, and we can trigger those actions using policies. Our custom policies can trigger on availability, health rule, and performance events. And once these events occur, you are then tracking them with your policy, and then you can trigger actions. These can be things such as creating JIRA tickets or sending Teams messages in Teams channels. And you can even separate it by hours. So you can create specific health rules and policies for prod support teams that work during the day, and then specific policies and actions that work for prod support at night. So you can get it to the right person at the right time so they can make the actionable response in a good time and reduce your mean time to repair. Now, with these proactive monitoring tools, you can stay ahead of your issues and then ensure a great experience for your users. And the next thing I'll do is go into our demo. Give me a few seconds here. Okay. So in our demo, we're going to be going through our APIs page in our AppDynamics. Now, to get to our APIs page, you'll go to your AppDynamics home screen, go into user experience. You'll click on API monitoring here. And if you didn't have a collection, you can create your collection here. We already have our collection, so we'll click into our Expert Insight series, and you'll first be greeted with your jobs. As well, you'll have your sessions, APIs, alert and respond, and metric browser, all of which we'll go into at later in this demo. But the first thing I want to do here is I want to create a GUI option. So let's create a new job here at the top. We'll call this EIS Series 3 GUI. We'll select our GUI option out of the 3 options. And here we can make our API requests. So we're going to be doing a get against this Ron Swanson quote generation API. But you can use any API you want. Here, we can do any extra things that we need for our API, such as headers, anything in the body, whether it's a JSON or XML. We can set parameters, do authentication through basic or token, as well as response validation. So I'm going to look for the response code of 200 to make sure this worked correctly. We can initialize variables. And then finally, we can follow redirects and set a maximum redirect count. The next configuration option we had, again, for geo-distributed testing that I was talking about earlier, is selecting our agent locations. The first thing we have is our option between hosted and private locations. Now, private locations are great. You do have to install them on your own agents, but they're great for getting private API endpoints that are only available on your specific servers. We're going to select hosted for our session today, and then we're going to select a few locations so we can do geo-distributed testing. Then you have the option between testing all locations every time or one location every time on round robin. I would say 90% of the time you're going to select round robin unless you have a low, because it would be running way too often. If I was running it every 15 minutes with all locations, we'd be having 16 sessions a hour for one job, which is quite a lot and quite a lot of licensing. Maybe if it was a very important endpoint that you don't care about eating licensing, you just want to know, you could do that. But I recommend using round robin most of the time. Another good example of using the all locations though is if you have a more irregular schedule. Let's say you only do it post release, or you only do it once a day, and you want to make sure that you fully utilize geo distributed testing. That's a great example to use that test all locations every time. Now, speaking of schedule, we can get as granular as you need. So you can run it against minutes, hours, and days. You can select specific time zones to make it make sense for you. You can run it between specific hours. So let's say we only want to run it during off hours. This is an internal site, and employees are only using it from 9 to 5. And we want to use synthetic monitoring to, it's called, supplement those off hours or off days. If we wanted to do specific timeframes, let's say a post-release, we wanted to do a heavy API test post-released for the next 10 days to make sure we're not seeing any issues post-release. We could do that. And then we can check specific days. So again, if let's say our weekdays we have a lot of user traffic, but our weekends we don't, we could set that as well. We can set multiple schedules. So all those things I talked about, those can all be true in statements, and we can mimic that using our multiple schedules. The next thing I want to talk about is timeout. So for this, all we're doing is a simple get. So 15 seconds is honestly more than enough. I would argue 5 seconds is probably a better call. But the more complex our scripts get, the higher timeout period we want. And again, we don't want it so high that we're eating up license count because it's taking forever to actually trigger your timeout. And then our final job option is our performance thresholds. This is where we create performance events that we can trigger our policies against. And we can do this against total response time. So you see here, we have a default of 5,000 for warning and then 10,000 for critical milliseconds. And then other options you can do is you can do it against 2, 3, 5, or 10 consecutive failures, as well as do automatic retest. This is great for getting rid of false alerting. And I think more people should use these settings, especially if you're doing rigorous testing quite often. So we'll hit save for now, just so I can show you what the results look like. I messed up one thing. Oh, rename that to GUI2. Hit save, and then while that's running, I want to show you next how to do Postman. So I already have a Postman collection, and this is actually what we'll be manually scripting later. But this is just doing a simple login. Then we're getting the user. So you see here, this one's specifically failing. So you're expecting a 404 error. And then this one's supposed to be a delayed response. Again, I'll show you all this later in our next portion. But to bring this into AppDynamics, you want to right click on your collection or hit these 3 dots, go down to more, and then hit export. And again, you want to make sure you're selecting collection v2.1, not v2. You'll hit export, save it, And then simply in AppDynamics, all you'll have to do is add another script, click on the import tab, choose that JSON file, and then just hit import, and it'll automatically convert those Postman collections to a script in JavaScript. Now let's look at a session. Let's look at that session for GUI and see what that looked like. So you see here in our sessions, we have an OK status. We see our start time, our name, our duration, and our response bytes, as well as our error codes. If we click into it more, we can see the APIs that we're hitting. In this one, it's only one. And then we can see specific details from our API, as well as our response details. So you see here, our status code is good. We validated that its status code is 200. And then we saw our payload, so we get our random run Swanson quote. As well, if we go back to the job here and click edit, you'll see that it actually converted it into a script. So you see that we have our request URL, we made our request, passing no headers or any options, and then we logged our response, and we asserted that our response status code was a 200. Now that was the GUI and the Postman, but now let's get into something a little more complex and show you how to do manual scripting. So the first thing we're going to show you is XML parsing. This is a simple XML file that I have here from the W3 schools. I think a lot of us who code have been on W3 schools. And this is different food items, as well as a description and a price and the calories. So we'll go into our code here and we'll create a manual script for this. So the first thing I want to do is create an assert. This is so we can do assertions later on. Again, this is the library that AppDynamics automatically imports. So we have that done. And then the next thing we'll do is I'm going to use this XML to do our XML parsing. And again, AppDynamics provides this. Now to start our API request, we're going to use an async. And then the first thing we'll set is our URL. And then the next thing we'll do is actually look for our response. So we'll set our response equals to await client.get. And again, this client's already built for us by AppDynamics, so we just have to call it. And if we're using our client object that AppDynamics provides, then it will appear within our AppDynamics response. Next thing we want to do is set our data to the response body. We're going to do a quick assertion for a response code of 200. And then we're going to parse our data. I apologize, I'm going a little quicker here just to make sure we get through this. And again, all this code is in that GitHub that I provided with a lot more information about the script itself with more comments. You see here with that response body, we'll use this XML2.js and parse the string and then log the results of that XML. And to see this in action, I already have the script running. But if we look at the individual session, we can see our response payload here with the XML. As well, if we go into the logs, we can see that we parsed and logged our specific breakfast menu. Now, I do want to do one more script today, and this one's going to be a little more complex. This has 4 steps to it. And this is using this regress, which is a public API test that we can do. And we'll be doing 4 functionalities. So the first thing we'll do is a login. Successful. Then we're going to use that login and the response token that we get, and we're going to list a user. We're going to get a single user. Then the next thing we're going to do is get this user fail. And then the last step we'll do is we're going to get a delayed response. So this will specifically delay how long it takes. So let's code this now. So we'll keep our assertion here. And then we'll create our async function. Again, for this one, I want to wrap it in a try catch because of how complex the functionality is. And the first step we'll do is we're going to create a login response object and do a post against our API login. And I'm going to pass through the headers and JSON that we need. So the headers contains the content type we want responded, the API key, or the content type that we're passing through, the API key. So this is the free API key that they have. And then the JSON. So we're sending our email and password. And then we're expecting a response of a JSON. Now, once we get that response, we're going to set a variable of token to that login response token, and then log that we got the token successfully. And that will be our validation as well. The next thing we're going to do is get that user. So we're going to use that token that we have and request a single user. So in the headers here, we'll use our authorization token. So that token we set here, we're going to set authorization bearer token. And then again, use that API key. We do have to use that for every request we'll be doing today. And then once we get our response, let's do a validation. So we're going to do an assert equals. And you see here, if I go here, our ID is supposed to be number 2. So we'll use the assertion and check that the ID matches correctly. Now, the next thing I want to do is check for a failed response. So same request pretty much, except we're checking for user 23. And we know this is going to be a response of a 400. So we'll do another assertion here and check that our status code is a 400, and we expected that failure. Now, our last one is this delay. So again, pretty much the same, the API users, but we added this delay functionality. We're passing through the same header, and we're expecting a JSON again. And then we're just going to do an assertion on what the data will retrieve, and I'll show you what the delay looks like when we look into our session. And then the final things I want to do here is I want to log what we've done. So I want to log that our login was successful, our get user was successful, and our user delay was successful, and all our tests passed. And then the final thing is I just want to close our try catch. So we're going to, if anything fails, we'll catch an error. We'll log that specific error message, and then we'll actually throw the error. And this is where AppDynamics will actually show on your session that an error occurred. And then the final thing I want to show here before we go back to the controller is you can actually create this locally. So I won't get into all the details on how to convert that locally right now. Everything that you need to convert it locally, I included in the comments in the GitHub. But the cool thing about this is because we have it run locally, we can actually put breakpoints. And then if we debug it locally in an IDE, we can see each individual step. So we see here that we returned our token for our first login step. We can see that our user response here. So this looks exactly right. Janet Weaver, ID 2, and then any support URL. The next one we can check and make sure that the status code does equal 404, which is correct. And then our final one, you're going to see a delay here. And then we get our response data. So that's it for creating the scripts. Let's actually show what this all looks like once we set it up in AppDynamics. So this is our EIS Series 3. This is all we created. When we click into it, we can see the 4 API requests that we did: the login, get user, the get user that returns a 404, and the delay. First thing we'll look at here is the delay. So we'll see that our response time is a whole 3,200 milliseconds. When compared to the regular get user, which is 281, we can see a stark contrast. And this is where we could start alerting on the specific endpoint and say, hey, this is taking forever. Let's take a look at this. And if you had it set up with the BT, we can go into the APM tab here and see why that might be taking so long. The next thing here is we can confirm that we're getting a status code of 404. And the final one you can see here in our response payload that we're getting our user properly. in our session. Now I want to show you the same thing I have set up, but we have one that's failing on purpose. And you'll notice here, I'll go into the more, but you see here that it's failing on the availability. And then this one's failing on the performance. And the reason this one's failing on the availability is if we click into it, we see that our 404 is failing because we're testing the script assertion, and this is important for the log, right? This is where we log correctly. Our test script for assertion failed. We expected 200, but we get a status code of 404. And because we logged it properly, anyone who's debugging this specific session can make that quite clear that we're not getting the response that we're expecting. And then we can dig into that from there. The next one thing I want to show is performance thresholds. So important thing to notice here is that the availability trend's actually okay. If you look into the session, it looks perfectly fine. But the performance threshold is failing and you see a critical threshold violated. And the reason that's happening is we set up our performance thresholds that we set up before, but we have a very small performance threshold, 10 milliseconds and 100 milliseconds for warning and critical. And because we're hitting those thresholds, we're now creating performance events that we can alert on. Now, the next thing we want to show off is our API page. Again, this grabs every job that hits a specific API endpoint will contribute to the requests of this API endpoint. So this is our first one. This is our get user login. And you see here, this is the response time only specific to this API. It doesn't involve all the steps that include in the script itself, which is really good for our testing. We can see the number of requests we have. We can select specific collections. So not only does this grab the jobs that hit this API endpoint of this Expert Insight Series collection, but any other collection that you have. You can see status code trends, and again, this can all be alerted on, and you can make this into custom dashboards. You see response time trends, wait time trends, TCP time trends, and all this is essential for monitoring key API endpoints. And now going into proactive monitoring. Again, we have the difference between API and synthetic monitoring jobs. So when we select our entity, we have our two options, which is those API endpoints are synthetic jobs, and those do have different metrics. We can select if we want to specify specific APIs, or if they specifically on doing it manually, or if they match specific criteria. And then we can set our thresholds for specific metrics, right? So we have all those metrics that I showed you before. In this case, we're looking for server errors and 500 server errors. And we're looking against the dynamic baseline. So our dynamic baseline will set what our normal behavior looks like. And then we can use standard deviations to alert on them. Same thing here with total time, synthetic API total time. And then here you can see the evaluation of our API endpoints, and if there's any evaluation events. And then same thing, we can select it for synthetic jobs. So here we only have that series 3 selected, and we're looking against availability and script errors. The important thing here to note is that for availability, we're doing a static threshold. And a lot of people don't understand availability because it's run as PPM. And the reason that's done is AppDynamics can only take in integers, it can't take percentages. So to make this a percentage, and I think to make it more easier to understand, you'll divide this by 10,000 and you'll get 99.98% availability is what we're checking against. So whenever it drops below that threshold, we'll trigger an alert based on that. And then finally, we have our policies. So our policies can trigger on the 3 main synthetic events. So any health rules that we created for synthetics, any availability events. So the one that's purposely failing, that this would trigger for a error. But you can also do it for warning, confirmed after a retest, or problem ended. And then synthetic performance. So that synthetic performance thresholds that we set. And then finally, we can set it for any errors that occur within our synthetic scripts. We can also set the scope, so we can only trigger on certain health rules or certain objects. And then finally, set the actions. So it's important to understand that scope is great for who we want alerted. let's say we create Jira tickets for any incidents, and we want to set up our Jira tickets based to trigger to certain teams based on certain jobs, right? So certain API endpoints are for certain teams, and certain API endpoints are for other teams. We can set up multiple policies and then set either our object or health rule scope to trigger only for those specific endpoints that matter for that team. So you always want to consider that when you're setting up policies. Don't just do blanketed. Really think about the situation, who needs to be alerted, and how they can respond to it. And that's it for the demo. I will finish with some closing thoughts on our Synthetic Expert Insight series, session 3, Advanced API Script Building. In today's session, we went into the methods to create API synthetic scripts, showed some features and some best practices. Then we went into how to set up proactive monitoring, and then I showed that all off in our live demo on our controller and showed you how to follow along and create your first advanced API synthetic script. Again, please check out the GitHub so you can follow along and create your first advanced API synthetic script if you weren't doing it live. And hopefully you all enjoyed today's session. We will be having future sessions on other topics, the next being dashboarding, so don't miss that. But now let's get into our Q&A portion. And Chris, do you see any?
No, none have come through.
Okay.
If you guys have any questions, please post them in the chat and we'll read them aloud so everyone can get the benefit and we'll get them answered for you. I guess you did so good. No one has a question.
Give it 2 more seconds, but yeah, like it.
And don't forget, everybody, this is a recorded session. It will be out on our YouTube page. I spammed the channel a few times, sorry. So please use those links. Check us out.
Okay, I don't see any questions, so I will pass it off to you, Chris, to finish it up.
All right, so that concludes our third session on synthetics. Thank you, Mark, very much for walking us through. That was a huge amount of information to get on a topic that everyone's been asking for. So I hope this is helpful for everybody. If you guys have any feedback, please provide it to us either now or via YouTube. And we are more than willing to take that information, make these sessions better, add to our list of topics that we're going to cover in the future. We will have another session coming out. Look for those emails coming from our marketing team, and as well, we'll post it up on the YouTube again once they're done. We are constantly looking for, things that we can get you guys engaged. We hear you guys' feedback, and we just hope that you guys continue to join us on these sessions. Spread the word, invite your friends. We want to make this a big success and help you all learn what our customers are telling us that they want to learn. So thank you so much for making this a success, and be on the lookout for future sessions. Thanks, everybody.